Hey there, and welcome to a continued dialogue about how we graph trig functions. So next, we're going to take those transformations and try to come up with a function, a sine function. All right, so let's start with our base sine function. Y is equal to the sine of t. Now, if I know the amplitude is 5, I can go ahead and say that the amplitude here is 5. We can put it right in front of the whole function. And then next, if I say that this is going to reflect over the x-axis, then I'm going to need to add a negative in front of that 5. If I know that the period is 4 pi, that means that 2 pi over b will equal 4 pi. And so I have to actually solve for b. When I do that and actually isolate b, I get b to be 1/2. And so I am just going to put a 1/2 in front of that t, and that will become part of my function. All right, now phase shift, no phase shift, and no vertical shift. So this function is complete. Okay, so you kind of understand how this goes. Let's try the next one. All right, start with your parent function. Y is equal to sine of t. Go ahead and add the amplitude in. And we can go ahead and add the reflection since there is none, right? So y is equal to 3/7 times the sine of t. Now, we know the period to be 2 pi over 3. So that means I need to find out what b is. 2 pi over b is equal to 2 pi over 3. Well, that is easy because that means b must be 3. So our b value, which is the coefficient to t here, will be 3. Now I have a phase shift of right pi over 3. And I know that my phase shift is found by negative c over b. I know my b value to be 3. So I can actually solve for c by saying negative c over b is equal to negative c over 3. And I know that my phase shift is pi over 3. So now I'm going to use this to find out what c is. Negative c is actually equal to pi, which means c is equal to negative pi. So I can go ahead and add that into my function. All right, and then the last thing, which is the easiest, is a vertical shift, which is up 7. And we've completed that function. Okay, next example, we have our parent function, y equals sine of t. We'll go ahead and add the amplitude in there. Y is equal to 29 times the sine of t. We will add the reflection, which means we need to put a negative out in front of it, right? Y is equal to negative 29 times the sine of t. Now we need a b value for our period. So we know that 2 pi over b will equal pi. Okay, 2 pi over b is equal to pi. Well, that means that b will have to equal 2. So we can go ahead and add the 2 in for our b value. And now we can use our phase shift and solve for c. So left pi over 4 means our phase shift is negative pi over 4. And we know that our phase shift is negative c over b, but we already know that b is 2. So again, we can go through this solving process. Negative c over 2 is equal to negative pi over 4. So I can solve that and figure out that c is equal to pi over 2. Okay, so let's go ahead and add that into our function. All right, and then the last one is easy. We're going to take it down 210 units. All right, pause the video. You try this last one on your own, and we'll come back in a second. All right, welcome back. And here we are, this last example. Let's go ahead and go through this process like we have for the prior three. We're going to put the amplitude in where it belongs at 0.725 in front of sine of t. And there is no reflection, so I don't need to add a negative sign. I do need to solve for b, so I know that 2 pi over b is equal to pi over 3, which means that b will equal 6. Okay, so I'm going to go ahead and add that b value into the function, yay. And then for my phase shift, negative c over b will equal pi over 6. Okay, and I know b is 6. So that means that c will have to be negative pi. So we can go ahead and add that into the function. And then we can add our vertical shift as well. We're going to add 14.1. We're good to go.